In this question, identical resistances of values R each are connected along the edges of a tetrahedron. अब आप जानते हो tetrahedron कैसा होता है? Hedron, the word hedron means force, face, and tetra means force. I'm sorry, I'll have to smile again. This previous one is to be deleted. So start with a smile again. In this question, identical resistances of value R each are connected along the edges of a tetrahedron. Now you know what a tetrahedron is. Tetrahedron is a four-faced figure. So this is, you have met that in chemistry also, in tetrahedral bonds of carbon. So this is how, here is the drawing of tetrahedron. So there are these four faces and three rising resistors and three in the flat horizontal plane. Each resistance is capital R. Now between two phases, let's call them by between two vertices, call them by these names, and let's say these are the vertices, because since it is a symmetric figure, so any two vertices, the resistance would be the same. So I've chosen A and B, and we'll think about it. So basically current comes from here, goes through the circuit, all the resistances, and comes out here. Can you see that point D, maybe green is required, point D and point C, they are equipotential. These 2 points are equipotential. This is by symmetry. जैसे करंट यहाँ से जाकर के ऐसे आ रहा है, वैसे ही इधर भी उसी डिज़ाइन में जाकर के ऐसे आ रहा है. सो जो स्टेट इलेक्ट्रिकली स्पीकिंग पॉइंट डी का है, वही हाल पॉइंट सी का है, एंड दैट इज़ वाई देयर इज़ नो रीज़न why the potential would be different. So this is the argument of symmetry. Potential at C is equal to potential at D. So potential difference across CD resistor is 0. So there won't be any current. तो अगर हम इसको यहाँ से हटा भी दें तो भी कोई सर्किट में फर्क नहीं पड़ेगा. So well, eraser, will you please come out and erase this CD? So अब मैं CD हटाने वाला हूँ. Let's see what will happen. What will happen, I meant, will I be able to erase it nicely? I managed to do that. So back again. So now this is the circuit. Can you see this part AD and DB, they are both in parallel, each one is R. So total resistance of this part is 2R. And similarly this horizontal one, AC and CB, they are in series, and together they add up to 2R. So two pieces of 2R and this one R. All three are in parallel. So we have to add them like parallel resistors do. We'll first do 2R and 2R. You know, when equal resistances are added, it becomes half in parallel. So 2R and 2R together will be R, and that single R with this R between AB would be equal to R by 2. So that is our answer. So RAB, some people write it like this, others write R effective. So this is equal to R by 2. That's the answer. So where is R by 2? Sitting right here.